Hey guys, so I know you guys probably can't see me very well. Is that better? That's a little bit better. There's a light strip right here. So I've got this box of electric components. Can't see it very well because the light is so low. There's not much light. But yeah, I've got a bunch of capacitors, diodes, switches, wires, an electromagnet for some reason, and a whole heap of LEDs, and just some metal. I'm pretty sure it's aluminum, very, very, very thin sheet of aluminum, and a 330 ohm resistor. They're all sorted out evenly in these little spaces, and yeah. This little multimeter here, it's a digital one, and it no longer works correctly anymore. It does not give me accurate readings for volts, and volts is always what I use it for. So, now I just use it as pretty much just an LED tester. If I put it onto 200 ohms mode, it emits enough power through these to power LEDs. So right here, I've got a little warm white. It's just a little 2mm omnidirectional warm white. I have a whole whack of these. I have more of this color than any other LED, by far. Oh, the wire came out of my multimeter. I was wondering why it wasn't lighting up there. Get in. There we go. Positive. What the actual frick? Why are you not working? I have it on the right polarity and everything. Why is it not working? It's on 200 ohms mode. Why isn't it lighting up? It's weird. It's supposed to. We've got a little blue. Let's see if this one works. Negative terminal. All these LEDs, except for those white ones, so, like, half of these LEDs, I took off of circuit boards, so their wires are right teeny tiny. But these white ones, these warm whites, which are this color, these warm whites, they've got really long wires, because they were inside of these things. Holy crap. I can see perfectly fine here. This camera is so dark. There we go. Yeah, it's inside of this. This is out of a light strip. You know those light strings that you hang up on like a Christmas tree? This is out of one of them. This LED is exactly the same as that little one I showed you earlier. However, this one's a 5mm. This one's a 2mm. These ones are unique because their lenses are like inverse. Instead of a rounded part on the top, it's a little cone going in. It's got a little pit in the middle, a little hole. What that does is it makes the light come out the sides instead of the top. Reflects most of the light out the sides. Maybe this one will work. Yes, this one's working with me. See? It reflects the light out kind of everywhere evenly. instead of most LEDs, like this little blue one here, reflected out the, or well, not reflected, but the light comes out the top as a little circle, like a spotlight. It's a nice primary blue. Yeah, see how it's like pretty dim everywhere? What if I shine it right directly at the camera? And it's right nice and bright. Because of that rounded top there is a lens that makes it do that. The closer the little system is, see the little electronics inside of the LED? The farther those are away from the lens, the more downwards they are. The smaller that circle is, the more of a spotlight they are. If, like this one in here, if this little RGB oscillating light, like this one here, if you notice the system is, the lens is like sitting on the system. The system is just barely under the surface of the plastic. It's extremely close. What does that do? That also makes it omnidirectional. Almost. Actually, no, these two the same. So having a little pit in there, having a little hole on the opposite lens, a little cone going into the LED instead of coming out. You could also have it extremely close to the top of the LED. Doing both of those things have the exact same effect. Make it real wide. This has got a red, a green, and a blue light in it, and a little microchip. I don't think you can see the microchip. It's too small. It's definitely microscopic, at least. And as you can see, this is extremely dim because I'm only using a multimeter to power it, which is 2 volts, and sending out a current of 2. It's sending out 2 volts. I don't know how many amps, but only 2 volts. So these LEDs are very dim, and my LEDs are not sorted by voltage, which kind of sucks because I'm not able to test their voltage. The only way to test their voltage is to power them with 3 volts. The ones that survive are 3 volt LEDs. Most of them are 3 volts. This one's 3 volt. But, like, 5% of these LEDs in here are 2 volt. And you can't tell at all. They don't look any different or anything. They don't even look dimmer when I power it onto this. So, you just cannot tell. The only way to tell if an LED is 2 volts or 3 volts is to power it with 3 volts. If it blows up, it was a 2 volt. That's the only way to tell, is if you blow it up giving it 3 volts. The only way to tell if it's a 2 volt or a 3 volt. Now I'm going to do something with this little blue LED. I've been sitting here since the beginning of the video before I lose the freaking thing. Oh, never mind. I already showed you. I forgot. Now I've got another little blue one in here. I'm almost positive it's a 2 volt, because it looks quite brighter than these other ones here. When I power it on 2 volts, which is, well, this is a little bit less than 2 volts, but when I power it with this multimeter, it looks brighter than those other blue ones, so I'm guessing this one's a 2 volt. But I ain't gonna officially test it, because I don't want to kill it. I want to keep as many of my LEDs alive as possible. As you can see, it is quite brighter. My camera can't see it very well, but it is a nice primary blue. It looks very cyan-y on my camera, and very bright. You can't really see it very good. It just looks cyan and very white. But to me, it is a nice primary blue. RGB blue. Put that back in there. Now also, so I've sorted these out by color, these LEDs. So I've got miscellaneous, whites, blues, yellows and oranges, greens, and reds. So, and in the miscellaneous here, I keep that little RGB oscillating LED because, you know, I can't sort it by color. It's 3 colors. It changes. And same with this one. This is a bicolor LED. It's got 3 wires. It's got 1 negative and 2 positives. 1 negative and then 1 positive for each color. So I attach the negative wire onto the negative terminal. If I touch the positive wire onto one of these, it's red. If I touch it on the other one, it's green. It's a bicolor LED. So, obviously, this is multiple colors in one light as well. So I can't sort it by color. Throw it into the miscellaneous. And a lot of them, in most of my miscellaneous LEDs, are actually warm white. So you're thinking, well, why don't you just put them in with the whites? Because these ones have a resistor. Got that little resistor there. That resistor is red, yellow. 2, 4 times 10, 240. 240 ohms. You can power these with 3 volts, or 3 volts, 5 volts. You can plug these into a USB, and they'll power nice and good. With every other LED, all LEDs in the world are either 3 volts or 2 volts, I think, that I've discovered. Any of these, 5mm, 2mm, or 10mm LEDs, they're all 3 volts or 2 volts. So these ones, having a resistor on them, make them available to 5 volts. You can plug them right into a USB without them blowing up. 5 volts USB will blow up any of these other ones. So, since these ones are unique, they've got resistors with them, they're a different voltage than every other one, I throw them in the miscellaneous, because they're different. This one is too big to fit into one of these holes, but there is a certain place here that they fit perfectly in. It's a little circuit board with 4 LEDs on it. 2 orange ones and 2 green ones. They're all hooked up in series, so these can be powered with 10 volts. If you get, I'm pretty sure they can be powered by 12 volts, actually. But when I power them with 12 volts, they get pretty hot. They don't discolor or blow up or anything, but they feel warm. They start to feel warm pretty quickly, so I'm pretty sure 12 volts is a tad over. So I only give it 10 volts maximum. Power these with a 9-volt battery. And yeah, when I hook these up to the multimeter, you can't see them worth crap. You cannot see them. Because, you know, they're hooked up in series. They run on 10 volts. And I'm only giving them 2. I'm giving them 1/5 of what they can mostly take. So, they don't light up. They barely light up whatsoever. Luckily, I have got this little power supply thingy. I don't think I have it up here with me right now. No, I do not. However, I've got this. This is an LED powerer. It's designed specifically for LEDs. Put in 1 battery for 2-volt LEDs. Put in 2 batteries for 3-volt LEDs, and put in 3 batteries for 4.5 volts for blowing up LEDs. And because of the wiring I did, I'm not able to fit 4 in there anymore. This is just a 4 battery pack, but I added a bunch of wires and a button to it, so now it's an LED power. It's 3 volts right now, and there's just this little button here. Press it, now it's on. And yeah, you can hook this up to stuff like this. Little bicolor LED, let's hook this up, because why not? Alright. Green. It's a very yellowy green. Quite a lime green. And that's supposed to be red, but for some reason it's orange. Absolutely no clue why. There's a very bright green, very dim orange. No clue why that looks orange, a dim orange on that. When I power it with the multimeter, it looks red. So I'm guessing it got a little bit overvolted one day, and it got discolored. Yeah, that's probably exactly what happened to it. That's what happens when you overvolt LEDs, just a little bit, so they don't instantly blow up the moment you turn your thing on. You give them just a little bit more, like maybe 3.5 volts, something like that, maybe a little bit more than that. But if you overvolt them just a little bit, they will slowly discolor. They'll say, I've got a green one, it'll fade into an orange, and it'll get dimmer and dimmer and dimmer. It'll fade into an orange and then into a red. As it's changing colors, it'll, as I said, it'll get dimmer and dimmer and dimmer and dimmer. And it'll be really hot. And you'll smell stuff. You'll smell that delicious burnt LED smell. I don't see any black in there, so I don't think it's burnt. I'm guessing it is burnt, though, because, as I said, that red is like orange, and it's real dim. So it discolored. It got discolored, it got overvolted, and it discolored. Now I've got some oranges here. Oranges, not the fruit, no, I mean some orange LEDs. These are only 2 millimeters. And I've got 2 of them. Their terminals look interesting. Oh my goodness, excuse me. They're already, like, kind of shaped. They're already bent a little bit. They look, kind of like stairs. They're, instead of just 2 straight wires coming right out of the thing, they already have curves in them. They're already bent and folded and stuff. These are like a reddish orange, from what I remember. These are a 3-volt LED, because they run on 3 volts good. I blew quite a few LEDs trying to test their voltage, and I was like, you know what? No, frick that. That's enough of that. I'm tired of blowing up all my 2-volt LEDs. It's a negative. That's the positive. Oh. If anybody out there who is having trouble with finding out the polarity of an LED, here's how to find the polarity of an LED without just checking with wires. You put it on, you hook up this huge circuit, you put your LED on, you turn it on, nothing in your circuit works because you put your LED on the wrong way. Now you gotta take it all apart and everything. No, frick that crap, man. I'm talking from experience. Look at the system in there. So there's one part there, out of one terminal, that's a lot bigger. If you look, there's 2 pieces of metal in there. Oh, this thing's too freaking bright, man. I had a dimmer light. I don't. This camera cannot focus very close, so... Yes, there we go. So you see how there's 2 metal pieces in there? One of them is so much bigger than the other one. That right big one there is the negative. Okay? That big one is the negative. That little tiny one is the positive. So you put the terminal that's connecting onto the big metal piece in there, onto the negative wire, and the other one onto the positive. Now I'm going to finish hooking up this little orange. Come on now. There we go. There we go. That's actually a lot less of a reddish orange than I thought it was. I thought it had a lot more of a red tint. But no, apparently not. Yeah, it's a nice orange. It is getting a little bit warm. Which seems kind of strange, because it's not... If this was a 2-volt LED, it would blow up. But if it was a 3-volt LED, it wouldn't be getting warm. So it's like in between, and it doesn't make sense. And I've got this one here. It's 3 volts. Amber. I like amber. It's a very nice color. No, not Amber Heard. Frick that. Frick that. Frick that woman. She's a piece of shit. Anyway. Yeah. I like amber, the color. I like amber, the gemstone. But I like amber, the girl? No, I do not. Most definitely not. Look at this little amber light here. Amber is the color that's used on warnings. So, you know how the back of, I'm pretty sure Japanese cars, their blinker lights on the back are that orange color? That's not orange, that's amber. One sec. Hey guys, sorry about that. Turn on, light strip. Come on. Here we go. Infrared. Infrared. But yes, those infrared remotes, they don't work good, man. I don't really like them. I like radio signal much better. These, you gotta aim the freaking thing directly at the sensor in order for it to work. Yes, cameras can see infrared for some reason. Cameras can see the light of infrared LEDs. Yeah, amber. This is the same color that's on caution lights. So like, you know those big signs that are like an arrow pointing that's flashing on and off? That like orange arrow? That's amber. Those flashing lights on the tops of trucks? That's amber. Yeah, amber is the caution color. This is the color that means caution. Hey, warning, there's something going on here. Back the frick off, would ya? I took this little circuit board LED out of RC helicopter. Yes, this one's a little circuit board as well. Yeah, excuse me. It's just a little teeny tiny circuit board. We got little resistors. It's got them little resistors on it. I'm guessing it's probably... Well, I think of it. I think those are 2-volt LEDs. But they've got resistors. So they can work on 3 volts. But yes, 2 little teeny tiny little ambers. I have quite a few different greens here as well. Here's a little grand. Multimeter still on. Oh. These, warm whites are 3 volts. I'll power one of these fully for you. Sorry, guys. I'm having terminal connection troubles. Yeah, we got ourselves some warm white. Oops. Come on. Touch the wire. There we go. Okay. Yes, warm white light. Oh, speaking of warm white, also in my little miscellaneous, section, I've got one light. This is the only light that I've got that is not an LED. It is an incandescent. I just dropped that piece of crap. Where is it? There it is. Little teeny tiny little incandescent. Where's my flashlight? There it is. Little halogen. Why the frick are these called halogen bulbs, man? They're not halogen. The little metal in there is tungsten. It's a metal. It's definitely not a halogen. And the gas in there is argon. Argon is a noble gas. It's not a halogen. Why are these called halogen bulbs? They should be called freaking argon bulbs or tungsten bulbs. I've heard them called tungsten bulbs before. That makes sense. I've heard them called incandescent bulbs before. That makes sense. But halogen? Where did that come from? Where'd that name come from? For some reason, the little wires that come out of this one are extremely tiny. The reason I have this little guy is because I took apart an electronic device. I'm getting all this crap out of taking apart electronics. All of this crap in my components box, all taken out of old electronics. But yeah, old broken electronics. This is the oldest thing I've ever taken apart. It was... excuse me. It was a, adding machine from many decades ago. An adding machine. It's like a great big calculator. It's like the size of a cash register. You got your big keypad and everything, all your operations. And a printer. It has a little printer in it. The printer is about this big. And it prints your calculations onto like a receipt-size paper. This little electromagnet that I mentioned at the beginning of the video here, this also came out of that. This came out of the printer. Well, these both came out of the printer. This is a little electromagnet. You put electricity into those wires, and it makes magnetism. That was made as a little, like, gear shifter thingy for the printer. Like, when that turned on, it would move a gear a little bit and shift. This little light here, this was before LEDs were everywhere. This was in a place that an LED would be if it was made more recently. Yes, this was doing the job of what an LED does now. It was just sitting on the circuit board, just sitting there. Just like a little 2mm LED. It's a 2mm halogen. And it was sitting there. In one side of the wheel, there was this little wheel that had a whole bunch of little rectangles in it. There was this halogen bulb on one side, and a sensor on the other side, a light sensor on the other side. It shined the light through that thing. As that little wheel turned, it would sense the pattern of the light changing to sense which direction it's going and how far it went. That's also how mice, you know, computer mice, worked, before that, the laser ones we've got now. They also used that system. They shined light through a little wheel with a bunch of holes in it. Oh my god, these terminals are so tiny. It's so hard to work with this thing, man. Oh, that's still on. Oops. This thing can work with much higher than 3 volts. This is not a 3-volt light. It's meant for higher than that. And there we go. We got a little halogen. Looks very orangey to me. It looks a lot more like warm white to you guys. And yeah, just little teeny tiny little halogen. That's in my miscellaneous because, you know, it's special. It's a halogen. It's not even an LED for frick's sake. Got a lot of different little greens. This one's got some longer terminals, so I'm gonna use it. Oh, frick. I took this little green one out a bit ago. And then I got talking about the halogen instead. I'll hook up this little green. You know what? I've got a lot of greens. I'm gonna risk it. I'm gonna throw this onto 3 volts. If it blows up, too freaking bad. I also don't mind blowing up those warm whites, because I've got so freaking many of them. I don't care if I blow 1 or 2 up. I don't care if I blow 10 of them up. I'm never gonna use them all. Shut off. Thank you. Keep forgetting to turn that off. So, I've got this... I was about to tell you about this, but I got this little power supply thing. It's a transformer, 120 to 12 volt transformer, and yeah, and it's got a rectifier on it as well, so it's DC, and I use it to power that LED circuit board I had. Where the frick is it? It's here somewhere, gosh dang it. Ah, there it is. Yes, this. I power this using that. I can power that halogen bulb using that. And yeah. Yeah. Yeah, 3 volts. Yay, it didn't blow up. Yes, it's a nice green. Now I'm gonna take a different green. This one's got some longer terminals than usual in most of my other LEDs. What the actual frick? That was weird. It like flashed at such a perfect rate. For a minute there. It's a very nice lime green as well. Very yellowy. Doesn't look very yellowy to the camera though. It probably would if I changed the white balance. The white balance is incorrect on this right now. Wish I could change it while I was recording, but I can't, man. I can't, man! At first I thought it was getting a bit warm there. Yes, very yellowy, very limey. Green. Off. There we go. And I've got a lot of reds as well. And we're gonna go back in time again, just like we did with the halogen. We're gonna go back to the rectangular LEDs time. They don't have a lens or anything, they're just rectangular prisms. This is a very dim red boy. It's 3 volts. My multimeter's still on. Also got some very long terminals. I like the ones with long terminals. Those with the short terminals are so hard to work with, dude. There we go. Very dim little red. Omnidirectional. Doesn't have a lens or anything, so it comes out all sides. It's definitely brighter at the top. Just a little bit. It's interesting, this one. I like it. Just because it's cool how half of it is like... Why is it getting warm? Man, these all seem to be getting warm. This is... Frick, maybe these batteries are giving a little bit too many amps. They're overloading it just a tiny bit. But yes, I like this one because half of it, these terminals are very rusty. It doesn't really like to connect much. It was outside for quite a while. The device that the LED was in, it was outside for a long time. I found it on the ground, and I took her apart, and I grabbed some crap out of it, a few capacitors and an LED. I like this one because it's like, you can see how it's like half red, or it's like half lit up and half not lit up. And it's so dim, even though you're giving it full voltage. And it's just a very nice red in general. You can't see it very good on my screen because it's very low saturated. I don't know why I'm putting the LED right onto the camera. But yeah, it looks a lot more of a red to me. Much nicer of a red. Off. Yeah, so this is getting warm. Weird. Get off. There we go. This is also a very nice red. Come on now. Oh my god. Oh my god, stop. Please don't be 2 volts. Yay. Rick. You never know, man. You never know. Frick, you know what? I've definitely got more than one of all the LEDs I've got. So, I'm gonna power them all with 3 volts. And if it's a 2 volt, good frickin' bye. I'm gonna get them all 3 volts. Get rid of all the 2 volts. Luckily, not very many of them are 2 volts. It's a very nice red. I like this red. Just a perfect primary red. Oop. Connect and stay connected, please. It's being really annoying. Oh my god, this wire. Okay, shut off for a minute. The other one came off. Yeah. Do you understand how difficult it is working with these gosh dang tiny terminal ones? Oh my god. I want to buy some of these things. I'm going to buy some at a store. I know you can buy packages of LEDs on Amazon. I saw a few of those packages. There's like 450 LEDs in a package. You've got red, greens, blues, yellows, and whites. It's cool. 90 of each. There we go, finally, geez. Now, how far away the little system is from the lens determines the size of that circle. So if the machine is farther away from the lens, that circle would be smaller. A good example of this is with that little LED circuit board. That LED circuit board, the LEDs on that are pretty interesting because they've got the systems are not the same. See, the orange ones are down lower than the greens. The orange ones will appear brighter, and they're more like focused. They're more zoomed in. Their circle is smaller. The green ones appear a little bit dimmer because the light is spread out around a bigger circle. I'm gonna go grab that power supply I've been talking about here the whole video. Hold on. I'm gonna grab my 10-volt one. I've got two of these little things. One of them is 12 volts, one of them is 10 volts. I like this 10-volt one because it's AC and DC switchable. I built it so that you can switch it between AC and DC whenever you please. You can switch if it goes through the rectifier or if it just goes straight from the transformer out the output. And here it is. My power supply I built. Well, one of my two power supplies I built. This one's quite smaller. It's 10 volts. So, there's your negative wire, this green here. This long green one here. This is your negative, and this is your positive. These wires used to be kind of glued down. They came a little bit undone. Yeah, you can see the capacitor and the diode in there for the rectifier system. And there's this little switch. That switches to AC and DC. And there's this switch up here, which is your, just, you know, you're on and off. Now, I'm gonna plug this into the wall here. My plasma balls are kind of in the way back there. Yeah, I'll show you. There's my plasma ball. Well, one of my two plasma balls. I'll turn my other one on here. There we go. This one plugs into the wall. It's a 6-inch. This one, excuse me, is battery operated, and it's a 3-inch. You notice how they react with each other. It's pretty neat. The battery operated one reacts a lot more because it's lower power and it's smaller. So the big one kind of dominates it, and yeah, so you can see quite a big gradient of that reddish orange in the small one from where it's connected there. Plasma balls are cool, man. I'll show you these and then I'll plug in my power supply. It's so freaking cool. I love these things, man. So a neat thing about these you can notice is that this one is a bit more of a red color. Why it does that is because this one has more neon gas in it. This one has less neon. Neon is one of the few gases that's in here. I'm pretty sure there's 4 gases. Neon, argon, krypton, and xenon are in here. It's like 90-something% neon, and there's only a little bit of everything else. But if it was completely neon, all the things in there would just be a red-orange. But with the argon and krypton and xenon that's in there, it gives it that pinky effect and those blue strands. And oh my god, did they ever smell like ozone, and I love it. For some reason, this one's got a little bit of a problem. It was doing that since I got the pack. It was doing this problem since I got the package. Since I got it. It was doing that since I took it out of the package. And the problem is that if you leave it running for quite a bit, I might not get it on camera, but if you leave it for a while and then you touch it, it'll shut off for exactly 1 second. It'll turn back on. You try to touch it again, it'll shut off. And if you keep holding your finger there, it'll shut off. Blink, 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 and I don't know why. There's just, after you leave it on for quite a while, it starts to not like touching your finger. It starts to shut itself off for a second when you touch. Oh, a cool thing about these two is that this one's off here. If I do this, see how I'm touching it? Since there's a lot more electricity coming out of this one than this one, the electricity goes through this plasma ball, and it literally goes into this plasma ball. It transfers from plasma ball to plasma ball. And as you can see, I let go, and it's now arcing from this plasma ball all the way to the middle of that plasma ball. It's arcing all the way into the middle there. It's so cool. That is really neat. You take it apart, or pull them apart, and it stops. And yeah, are you doing the weird thing yet? No, not quite yet. No, it's touching a wire that's back there. Alright, now I'm gonna plug this power supply in. I took the transformer of that power supply out of a cassette recorder. Ah, frick, I'm gonna have to unplug this piece of crap. That sucks. Frick's sake. There we go. Alright, now this little power supply here is plugged in. Now I gotta change positions again. I gotta get back in here. Alright, I'm back here. I've got my little power supply. DC mode. The way I said it like that. DC mode. I kinda sang it. Wish I had some little tiny alligator clips. I put them on the end of my power supplies. So instead of just bare wires, I have to wrap them around the terminals, I could just alligator clip them. The negative wire was being way more friendly with me than the positive. The negative one actually went in pretty good. Oop. And there we go. Look at that. AC. DC. AC. DC. AC. DC. Yes, don't worry, you're not alone, man. I'm also thinking about the band. If you notice, when I... the frick? It's unplugging. If you notice why they're fading away like that, it's because that capacitor in there is slowly draining out. And this switch, it cuts off the output. So when you turn it off, it immediately clicks off. There is no fade away. But when it turns off and it fades away, that means it unplugged. That means I'm having some connection problems over here. Alright, there we go. Yes, if I switch it, as you can see, well, it doesn't really work on this camera mode, because they still look like they're flashing. But those are not flashing. You can tell by the line. To me, it looks like just a straight line. It doesn't look like a dashed line. If I switch to AC mode, if you notice they're flashing. You can actually see them flashing this time. DC, AC, DC, and yeah. Because the AC, because LEDs only work in one polarity. When the AC kind of fades into the other polarity, they shut off. They turn on, they shut off. So, AC is going like, say this is, my hand here is 0 volts. And like up here is positive 10, down here is negative 10. AC goes like, it's always switching its voltage in a sine wave, but very fast, much faster than that, 60 times per second, 60 hertz. But since the LEDs only work when it's a one polarity, they're kind of doing this. So they're not going in a perfect sine wave. They're turning on and off instead of just like bright, dimmer, brighter, dimmer, brighter, dimmer, brighter, dimmer. They're going brighter, dimmer, off. Brighter, dimmer, off. Brighter, dimmer, off, like that. But really fast when they're in AC mode. So that's why they look a little bit dimmer, is because they're flashing. And yeah, that's my little power supply here. I'm gonna hook up that little... Why am I talking so fast? I'm gonna hook up that little halogen bulb to it. These things can power that. My big one can power that, so I'm guessing my little one can too. If 3 volts can power it, I'm guessing 10 can as well. If 12 volts can power it without blowing it up, then I'm pretty sure 10 volts can as well. This thing can run on 3 volts and 12 volts, so it can most definitely run on 10 volts as well. Yeah. Now this type of light works how I explained before. Not like an LED. It's like brighter, dimmer, brighter, dimmer, brighter, dimmer. It turns on no matter what polarity. Because they're not a diode. They're just a little tiny tungsten wire inside of a vacuum tube. Oop. Yes, very bright. Ouch, my voice, that voice crack though. Very bright. That's actually a lot brighter than I remember, man. That's very nice. Very nice. I love that incandescent color. It's beautiful, man. It's a little hot. Get off. Come on. Come on. Get off, you piece of crap. There we go. Oh, frick. I forgot to show you what it looks like on ACK mode. I gotta hook up all this crap again. Fix it. This green wire, this negative, is interesting because it's not a whole bunch of little tiny pieces of copper. It's one piece of copper. Instead of a whole whack of little tiny slivers of copper wire, it's one great big thick wire of copper. So, it doesn't really flop around. It bends and stays there, kind of like twist tie. It's one big metal wire instead of a whole whack of little tiny ones, like every other wire is. Turn it on, DC, AC, DC, AC. See how it doesn't really change brightness much? It does get brighter on DC because the rectifier increases the voltage a little bit. But on AC, as you can see, it's not flashing. The LEDs were, you can see them little blinking when I did that, but it's not flashing. And these halogens also, because they've got a little cooldown and warm-up time, it takes like 0.1 of a second for them to heat up, and it takes like 0.1 of a second for them to cool down. The AC switching, when it goes down to 0 volts, and then it goes back up to minus 10, it's like plus 10, 0, minus 10. When it goes down to 0, and it goes back up, and it goes to minus 10. It's too fast. The light does not really cool down at all, because it's already back completely on by the time it even starts to cool down a little bit, so it does not flash at all. If LEDs were able to, LEDs do not have that kind of cool down and warm up time. The moment you turn it on, boom, full brightness instantly. The moment you turn them off, boom, nothing instantly. They don't have a little like these do. My video is about to run out of time. It only lets me record an hour at a time. So I'll have to see you guys in part 2 in a bit here. Can't see, I'm blinded by the frickin' thing. There we go. It's like, you know, when you look at one bright light for a bit, and it makes that one little part, one little dot in your vision where you just can't see anything. It's annoying. But yeah, that's that. I showed you all my LEDs, didn't I? I did. I freaking did. No, I didn't show you that multicolored one at full brightness. I didn't show you a blue one at full brightness either. Let me show you a blue one. Oh. That was close. You guys are probably yelling at me like, oh, no, don't hook up the LED to your 10 volts, Charlie. For frick's sake, you're gonna blow it up. Took me a moment to realize I was wiring it up to my high voltage power supply instead of my little LED power. Oh, and also, I've got this wire here. It's just a positive and negative wire. It's 2 wires. They're taped up into one kind of thing. So they split off into 2 at both sides. See you in part 2, everybody.